So now we're going to be doing something called trig identities. These are essentially proofs. So we're going to prove, I'm going to tell you something that is true, and you're going to prove that it's true. And generally, it's going to take the form of, there's going to be something equals something. And what we're going to do is we're going to call the thing on the left, we're going to call it the left side. And we're going to call the thing on the right side. And you're allowed to work on both sides. But what you're going to do is you're only going to work at one side at a time. So essentially, it's going to be left side equals, and you're going to play around with that. Or it's going to be right side equals, and you'll play around with the right side. And then, when they look exactly the same, you're going to say left side equals the right side, and, QED, which is Latin for showed you. It means something else. Go look it up. But it shows, it's like a, yeah, I got it. That which was to be shown type thing. Okay, so here let's start off with the first one. So we have cos of x, tan of x, sine of x equals 1. And what we're going to do is we're going to play around with it. But actually, before we start, I'm going to give some guidelines on what to do. So generally speaking, we're going to work on the more complicated side. So the guidelines are going to be work on more complicated side. We're generally speaking going to take the tangent and turn them into sines over coses. Unless there's a tan on both sides, then maybe not. You're going to combine fractions. So if you, for example, if you have like a fraction over a fraction and minus a fraction over a fraction, and you're going to turn that into one kind of fraction. Maybe I shouldn't have used the lefts. But if you have two fractions, you're going to try to use a common denominator. So essentially, using common denominator. And if you've done all those and nothing much is happening, then you're going to use the what they call the Pythagorean identities, which is the sine squared theta plus cos squared theta equals 1, and the various ones that look like it. So, back to this one over here. We should probably move that around. So cos theta, cos x, well, I'm using x instead of theta. Sometimes I use x, sometimes I use theta. It's pretty much the same thing. Cos x, tan x, sine x equals 1. This side's more complicated. I'm going to work on the left side. So I'm going to say, okay, so the left side equals, and what I'm going to do is I'm going to start off by taking that tan and turning it into a sine over cos. So it's going to be cos x times sine x over cos x all over sine x. And we could see that these cos x's cancel. So the left side is equal to sine x over sine x, and sine over x over sine x equals 1, which is the same as we had over here, which means that the left side is equal to the right side, and that is what we were trying to show. And so we proved it. We have proven now that cos x, tan x, sine x is equal to 1 no matter what. Okay, this one looks a little more complicated. The left side, we have a right side. The right side looks a little more complicated. We're going to mess with the right side. So first what I'm going to do is I'm going to take that tan, I'm going to turn it into a sine over cos. So it's going to be 1 over cos x minus sine x times sine x over cos x, which is equal to 1 over cos x minus sine x times sine x is sine squared x over cos x. The denominators are the same, so we can bring them together. So that's going to be 1 minus sine squared x all divided by cos x. Okay, so what are we going to do here? We're a little bit stuck. Not quite sure. Well, we're going to have to do one of the, we're going to have to use one of those trig identities. But which one are we going to use? We're going to use, let's see if I can find the other sheet where I actually summarized them. Right, so we're going to use one of the kind of the blue ones over there. And we see that 1 minus sine squared, it could go this way as well. So 1 cos squared equals 1 minus sine squared. 1 minus sine squared also equals cos squared. So 1 minus sine squared, we could write that now as cos squared x over cos x. We're kind of running out of room here. And so the right side equals, and cos squared x over cos x is just cos x. Which is correct, because, sorry, I was looking at that over there and I thought I was wrong. I was looking at the 1 over cos x, I'm like, something made a mistake. But no, the left side is cos x, the right side is cos x, so left side equals right side, and therefore this is true. This identity is actually true.